Hi everyone, it's Coach Fred here, and today I'm going to be going over the Algebra 2 Trig Honors test that you took as the end of your summer work. Now, this is actually going to be a long video. I might have to break it up into two, but I'm going to go over each problem, and so I suggest you take your test out and you kind of look at what I do and see what you did wrong. You really want to understand this trigonometry, and you did it on your own. So it means it's going to be a little bit more challenging for you. But again, I'm here to help in any way possible. So if you want to meet before school starts or even when school starts in the math lab, please let me know. All right, let's get to it. So it says express cosine 200 in terms of its reference angle. So now I got to remind you, a reference angle is a first quadrant angle that's an acute angle with one of its sides being the x-axis. So when I am looking for a reference angle, I actually like to draw it. I always like to use the rule of 4 and see a visual of it. So we always start our angles in standard position for trig. So that means the positive x-axis, I'm going to go around 200 degrees. So I'm going to be right about there. So that black line is the terminal side of the angle, okay? So the reference angle would be created with that angle and the x-axis. So we can see that it would be 200 minus 180, right? Because that's 180 degrees, so 20 degrees. Now you might remember that we're looking for the positive angle when we're looking for reference angles. So if I want to write cosine 200 in terms of the reference angle, I find that little acute angle, which is 20, and I write cosine 20. The additional piece that you need for this is you have to recognize that 200 is in the third quadrant. Cosine is the x values, and the x values in this quadrant are negative. So that means that I'd be looking for a negative cosine of 20. All right, let's move on. Number 2, it says find an angle coterminal. As a reminder, a coterminal angle will end in the same place as the angle itself. So think about that for a second. If I have an angle and say it's right here, I went from here to here. For me to have a terminal side there again, I could go around one time in either direction. I could go this way one more time, but I'd have to go either 360 degrees or 2 pi. So to find a coterminal angle, first identify, is it in radians or degrees? This is in radians because I see that pi. So if I have negative 4 pi over 3, I'm just going to add 2 pi to it. Now you might see I need a common denominator. So this would be 6 pi over 3. So when I add negative 4 pi over 3 plus 6 pi over 3, I'm going to get 2 pi over 3. All right, coming together. So complete the statement. As you were going through the unit circle, one of the things I was hoping you would see, and I'm going to look at the first quadrant for a second. Actually, let me go to a new page. So if I'm looking at the first quadrant in the unit circle, we know that the coordinate point here would have been root 3 over 2, 1/2. The coordinate, and that would be at pi over 6. The coordinate point at pi over 4 would be root 2 over 2, root 2 over 2. And the coordinate point here at pi over 3 would be 1/2 root 3 over 2. Okay, now I'm also going to look at this in degrees, so this would be 30 degrees, 45 degrees, and 60 degrees, and those numbers should mean something to us because these values come from 30, 60, 90 triangles and 45, 45, 90 triangles. All right, as a reminder, x and y, x is cosine and y is sine. So if you think about this, the sine of 30 is 1/2. The cosine of 60 is 1/2. Look at that relationship. All right, the sine of, the cosine of 30 is root 3 over 2. The sine of 60 is 1/2. Is root 3 over 2. So notice they are equal when their angles add to 90, so add each other's complement. The same is true at 45 degrees. So at 45 degrees, or pi over 4, my values are root 2 over 2 and root 2 over 2, the same value. So that's 45 and 45, which is 90. So they are equal each other's complements. So going back to this problem, the sine of 57 would be equal to the cosine of 90 minus 57, which would be 33. All right, a couple more. I'm just going to do this page in this video. So if I want to convert to degrees, so I have a radian measure here. Remember, radians are actually easier to work with. So if you're trying to turn everything into degrees, you're going to want to start thinking about it in radians. So 6 pi over 5, I would multiply by 180 over pi. And so the pi's would cancel. I'd want to simplify. So 5 goes into 180. I'll do the work over here. So 36 times. So 6 times 36 gives me 216 degrees. Okay? All right, converting to radians. If I have a 40-degree angle, a non-unit circle angle, it's easy to see. We would multiply, instead of by 180 over pi, the opposite, or the reciprocal, pi over 180, because we want pi in our answer. I'm going to simplify. And so that would give me 2 pi over 9. All right, determining the period of a graph. Well, we know that sine and cosine, when non-translated, their periods are 2 pi. That means they complete one full cycle in 2 pi. Now, to determine the period, we're going to be looking at the b values. So let's first remember that these are in the form a cosine b x minus c plus d. Okay, now remember, the first thing that you want to do, not the only way to do it, but this is the way I taught it, to pull out the b term. So I see parentheses here. The first thing I'm going to do is I'm going to pull out the 3. Okay, and so I can then see my b term. To find my new period, to find your new period, you take 2 pi and you divide it by b. So in this case, my new period would be 2 pi over 3. 2 pi over 3, that means that the full rotation of cosine, the full graph, is going to occur if I start at 0 at 2 pi over 3. So I'm going to see that full rotation of the graph, okay? Determine the amplitude of sine, of the sine function. Okay, as a reminder, sine's got that same form, so that's why these are so similar. And our amplitude comes from a, but it's the absolute value of a, because remember, amplitude is half the distance between the max and the min, so the average of the max and the min, so it's in the middle of the max and the min. Remember, we called it the midline. So while this is a negative, got a negative in front of it, my amplitude would just be 2. So that means from the midline, I'd be going up 2 and down or down 2. So be really careful. Negative is not part of amplitude. All right, determining a quadrant. So to determine a quadrant, let's think about this. We need to know what values are positive and negative in each quadrant. So I'm not sure this was in a video, but a little trick to remember is that they're all positive in quadrant 1. Sine is positive in quadrant 2. Tangent is positive in quadrant 3. And cosine is positive in quadrant 4. We say a mnemonic to help us. All students take calculus. And this mnemonic helps me find the positive values. Another way to think about it is that, again, cosine is x, sine is y. And tangent, another way to think of tangent is sine over cosine. Okay? All right, so let's think about this. So in quadrant 2, we know they're all positive here, right? Positive, positive. And so tangent would be positive as well. All right, here in quadrant 2, well, x's are negative, whereas y's are positive. So you can see sine would be positive, cosine would be negative, and if either of those are negative, then tangent's going to be negative. Okay, in quadrant 3, well, x is negative and y is negative. So sine and cosine are negative, which would give me a tangent that's positive. And then my last quadrant, okay, my x's would be positive, my y's would be negative, and again, that would make tangent negative. So let's now look at the question. Tangent is less than 0. That means tangent is negative. So that gives me this quadrant or this quadrant. But cosine is greater than 0, so cosine is positive. Cosine's x, so it's in this quadrant, so this would be quadrant 4. All right, that was page 1 of your test, and hopefully it was helpful. And if you still have questions, please let me know. Have a great day.